In these problems, we are doing some more work with sigma notation, the summation notation. And in these, we are given a series, and we have to use sigma notation to write the sum. And remember, sigma notation has that big sigma, and then it's got I equals something up to something else, and then has an expression. So the thing to do when you're given a series like this is look for what's changing. In these, the 9 and the 4 stay the same, so that's not going to have to do with I. But this number down here, first it's 1, then it's 2, then it's 3, all the way up to 8. So that is going to be I in our expression. And it starts at 1, so down here we say I equals 1, and it goes up to 8, so up here we put an 8. So the sum of this expression from 1 to 8 of, and then we just write this expression with I substituted in for the number that changes. So 9 over 4 plus I. And that's all there is to that one. If that confuses you, take a look at it in your head and say, okay, what if I substitute in 1 for I? I would get 9 over 4 plus 1. That's that one. And then if I substitute 2 in for I, 9 over 4 plus 2, I get that one. And it works. So you can verify it. Now this next one is a bit more complicated. There's actually a lot going on here. Let's look for what's changing first. So we've got this big expression with a fraction and a square root and a something squared underneath. First of all, I notice the bottom of the fraction changes. So it starts at 6, goes to 7, and then all the way up to 12. So let's say I goes from 6 up to 12. Let's just start there. Now, inside the expression, other things are changing too. We have 5 sixths, then 6 sevenths, then finally 11 twelfths. And what I notice is this number down here is the same as this number out here. So if this is I, then this can be I too. But what about this number up here? Well, in each of these, it's 1 less than I. So we could call that I minus 1. Now let me start writing out this expression. So we would have 1 over I, and then we'd have our big square root symbol, and we'd have the number 1, and then there's something else going on here which I'm going to leave a little space for. Here there's a plus sign, here there's a minus sign, then there's a plus sign over here. We'll talk about that in a minute, but let's work at what's in the parentheses. So I've got 5 sixths here. This is 1 less than I, so I'm going to write that as I minus 1. And this is the same as I, so I'm going to write that as I, and this is quantity squared. Okay, so we've got most of this done, but we've got this odd thing. What we have is an alternating sign here. It's positive, then it's negative, then presumably it's positive, and then negative, and finally it's positive again. And what you'll notice is that this sign is positive when I is even and negative when I is odd. And that's actually really useful to us because the number negative 1, if you raise it to an even power, it's going to equal a positive 1. If you raise negative 1 to an odd power, it's going to equal negative 1. So we're going to exploit that here to get this alternating sign. We're going to say this is 1 plus negative 1 to the I power. So what that's going to do, notice here, when I is 6, it's an even power. It's going to turn that positive, and so we simply have 1 plus this expression. Next, when I is 7, that's an odd power. It's going to make this a negative 1, so we have 1 minus this expression. And then we have to have our sigma out here, and our values of I, we said they start at 6, and they go up to 12. So this will give you this. And if you're not 100% sure on this, start plugging things back in, values for I, and see if it works out. I think if you check it, you'll find that's correct. So that's a little bit of work with using sigma notation to write out sums. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.